Hello viewers, in my student class video, we are going to see about engineering mathematics 2. So in that, we are going to see about vector calculus. So now we are going to find a Gauss Divergence Theorem using vector calculus. So here we have some notes for this problem. So our vector differential operator is what? Del. So del's expression is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. So del psi is equal to I vector dou by dou x plus j vector is equal j vector dou psi by dou y plus k vector dou psi by dou z. So this is the value of del psi's value. And now we want to prove Gauss Divergence Theorem. So we have a formula for Gauss Divergence Theorem is double integral base S f vector dot n cap ds is equal to triple integral v base v divergent f vector dv. So this S is referring a surface of a cube. This is S is referring a surface of cube or an object, and this V is referring a volume of an object or a cube. Okay, so here divergent f vector can also be written as a del dot f vector. So divergent f vector is also can be written as del dot f vector. So now we move on to a sum. So we have a question. Verify the Gauss Divergence Theorem for f vector equal to x cube I vector plus y cube j vector plus z cube k vector taken over the cube bounded by x is equal to 0, x is equal to a, and y equal to 0, y equal to a, z equal to 0, and z equal to a. So now solution. So given f vector has been taken and the cube bounded by x, y, z values have been taken up. So formula. So we want to find Gauss Divergence Theorem. So we have a formula double integral s base x f vector dot n cap ds is equal to triple integral base v divergent f vector dv. So now we want to find this whether surface and volumes are equal or not through Gauss Divergence vector. So Gauss Divergence Theorem, we are going to prove that. So now I'm going to take RHS, so the right hand side of the formula, triple integral base v divergent f vector dv. So now here a divergent f vector can also be written as a del dot f vector. So I have taken as del dot f vector. So we want to know about a del values. So del expression is what? Dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector. Now divergent f vector is equal to, so our del value we have, so our del value I have written dot, so for dot, and our f value is what? X cube I vector plus y cube j vector plus z cube k vector. So now we want to now we are going to do the dot product here. So now I vector dou by dou x I vector into x cube I vector is what? Dou by dou x cube. So j for now we are going to do the same with I vector with the j and k. We will return with the value of 0. So we don't want to write a 0. So just we want to we can write the value. So we have studied a product as I vector into I vector is equal to 1 and j vector into j vector is equal to 1 and k vector into k vector is equal to 1. If I vector into j vector or j vector into k vector, the values would be what is 0. So we have already known about this. So now just I'm going to multiply this. We would return with the dou by dou x cube and j with the j we would get dou by dou y cube and k vector with k vector z cube we would return with dou by dou z cube. So now we are going to differentiate this with respect to x and with respect to y and with respect to z. So our answer of divergent f vector would be 3x square plus 3y square plus 3z square by differentiating this x cube, y cube and z cube value. So we are written with our divergent f vector now. So we have taken a formula, the LHS formula. So triple integral base v divergent f vector dv. So we have find a divergent f vector. So in the place of divergent f vector I have written our value 3x square plus 3y square plus 3z square. And dv, so we have a x, y, z. So we have a boundary of cube values as x, y and z. So our dv will be what? Dx, so dy and dz. So this will be our what? Difference. So dy, dx, dy and dz. So we have taken as dv. So our limits are given for x, y, z. So x for x is 0 to a, and for y also 0 to a, z 0 to a. So we have taken our limits now. So now we are going to integrate this. Okay. So now we are going to multiply this dx inside of this equation. So 3x square dx and plus 3y square into dx and plus 3z square into dx. So now we are going to integrate with respect to x. First we are going to integrate with respect to x. Well, we all know how the integration process would be taken. So we have a formula x power n. So integral x power n as x power n plus 1 divided by n plus 1. So by using this formula we are going to integrate this x square and y square, x square value and y square z square based on the difference x dx or dz or dy. Okay. And so now with respect to x, I am going to differentiate this equation. So our the integration value would be, so for x square, x cube by 3. So x power n plus 1 by x power n plus 1. So 3 is constant here. So 3 x cube by 3. An integral of dx. So normal integration of dx is what? X, nothing but x. So integration of dx is x, 3y square x. So only the term x would be x can be differentiated. The other term is considered as constant. So don't confuse about it. So y cube x. So here 3z square is constant. So just we want to integrate what? Dx. So our answer will be x. So our limit of dx is what? 0 to a. So our x limit is 0 to a. Just I am taking 0 to a. So we want to apply this our limits in the place of x. So in the place of x we are going to apply this limits. So we all know the how to place limits. So for that we have our x limit is what? A and 0. So upper limit minus lower limit. Our upper limit is a and minus lower limit 0. So in the place of x we want to write like this. So at last we would get our value as what? A cube. So our value would be a cube. So same in the place of this x we want to write upper limit a minus lower limit 0. So 0 is not necessary. So just we can take a and 3ay square in the same process in this place. So in the place of x we want to write upper limit minus lower limit. So we would written with 3a square z square. So as per this process we want to write. So we have find out dx. So dx has been solved. So we have now a cube plus 3ay square plus 3a z square dx dy by dz. So now we want to find dy and dz. So by the same process, the above what we do, we want to repeat that. So for y we want to do that. So for x we have solved, for y also we want to solve. So for that I am just multiplying dy in the place of a cube and dy into 3ay square and dy into 3a z square. So now by the same process we have written. So now we are going to differentiate this with respect to what? With respect to y. So a cube is constant. So constant is a reminder, and dy while you are integrating dy with written with y. So here we have a y value. So integration of y square is y cube by 3. And here we have a 3a z cube y. So y this three terms are a constant. So now we want to only integrate dy. So dy is what? Integration of dy is y. So our limit of dy is 0 to a. So y's limit is 0 to a. So by the same process, upper limit minus lower limit, we are going to substitute this a and 0 in what? The places of y. So in the process of upper limit minus lower limit, a minus a. So here a minus 0 and here a minus 0 and here a minus 0. So upper limit minus lower limit we are going to do. So now we would return with a cube into a plus a into a cube plus 3a z square a dz. By adding the powers of a, we would return with a power 4 plus a power 4 plus 3a square z square dz. So now we have solved dx and dy. So now we want to solve dz. So again I am going to multiply this dz inside of this equation. So a power 4 into dz, a power 4 into dz, 3a square z square into dz. So now, so integration of 0 to a. So a power 4 dz plus a power 4 dz plus 3a square z square dz. So a power 4 dz will be what? Z, and a power 4 dz will be, while we are integrating, we treated with z, and here 3a square z cube by 3. The limits are 0 to 4. So in the place of z we are going to replace what? Upper limit a minus lower limit, and upper limit a minus lower limit, and here also upper limit a minus lower limit 0. So 0 will be cancelled. So now we have a power 4 into a and a power 4 into a and a square into a cube. By adding the power terms of a, we will have a power 5 plus a power 5 plus a power 5. So adding this a, we would get 3a power 5. So now, triple integral base v divergent f vector dv's value is what? 3a power 5. So our value of triple integral divergent v f vector dv is 3a power 5. So we have find our RHS. So our RHS value is 3a power 5. So now we want to find what? Our LHS value. So we have find our RHS. Now we want to find our LHS value. Till now we are completed with our RHS value. In our upcoming video, we would see about how to find LHS value of our equation. Okay. So don't forget to like, share, comment and subscribe to my student class YouTube channel. Thank you viewers.